today, let's go through some practices for chapter 5. So if you haven't downloaded the database, right, it's available within the chapter 5's module. So I am downloading this. Okay, so one more thing. Some of you asked me, I saved all the queries, right? But the second time I open it, I cannot find them. If that happens to you, this is the way to find them. When you first open this database, right, you go to this drop-down list. So here you can select what to be presented in front of you, right? So if you have saved queries, you check this. And then if you have saved queries, then you should be able to see them. But now this is a blank database, so I don't have saved queries here, so I don't have anything here. But if you have, then you should be able to find them. Okay, so before we start the practices, let's go through each table and understand what each table means, right? So the cash table obviously is giving us a list of bank accounts, right? So here we have 3 of them. Cash receipts table lists all the cash receipts or checks received from the customers, right? Customer give BBB cash. So from here we know the receipt date, the amount of the check, and from which customer, and which order is this cash receipt going to, right? The third table is the employees table. So this is just like a list of the employees we have, their information. And now the inventory table is just summarizing the inventories, their type. We also have 2 other tables for more specific inventory characteristics. For example, the fabric color, the inventory types. Retailer customer is just the summary of the customers. Retailer sales, this is the sales table, right? Because we have the order number, on which date was the order made, delivery date, the order made by which customer, processed by which employee, so on and so forth. Retailer sales item, this is a linking table, right? And this is a linking table of which 2 tables? Retailer sales items. What is retailer sales items linking to? Yes, right, inventory and sales, because sales has the primary key of orders. Inventory table has the catalog number as the primary key. Yeah, and this is a table to summarize what are the inventories that are included in each order, right? And also the unit price for that inventory and the quantity of that inventory. The last table is sales representatives. This is just like a list of the representatives that conduct the sales, right? So these are the individual tables. If you want to understand how these tables are interlinked with each other, you can take a look at the UML class diagram on the slides, right? So I assigned this task to you to read the case, to understand the UML, and also the mock exam actually gives you some questions related to this UML class diagram. So I will not cover this in class. I hope you can take a look at this after class, okay? So now our focus here is to go through these practices, and hopefully we can get to most of them. And next time I will do a review, and I will walk you through the assignment that you just did, and get you prepared for the midterm. Okay. So now let's take a look at the first practice. With the data set that we just looked at, what was BBB's total sales within May? Okay, that is to say between May the 1st and May the 31st. And here, let me ask you this question one more time, right? Because I asked this question many times, I think. So if we look at the retailer sales table, right, we have 3 dates: order date, requested date, and delivery date. So which date should we use in terms of revenue recognition? So if we say revenue in May, which date should we use to apply this condition, like to limit the state within May? Should it be order date or requested date or delivery date? Is it order? Do all of us agree? According to GAAP, right? You recognize your revenue when the products are shipped or when the services are provided. So that is to say, if we say, well, revenue in May, we actually are going to use the delivery date and impose the condition that the delivery date is within May. So that's the, you have to have some accounting knowledge in order to do this, right? Okay, so now for the first practice, I will go through this with you. But for the number 2, number 3, I will invite volunteers here, okay? We're not volunteers. I'll just call some of you to come on stage, okay? So let me just repeat like the general process of dealing with these SQL practices, right? So whenever you have a question like this, the first thing I would think about is what columns do I need to generate this number, and from which tables can I find these columns, right? So let's think about what columns do we need if we want to calculate total sales in May, right? So first, since we're already on this retailer sales table, we need this table, right? Because it has the delivery date. We need this information to limit to May's revenue, right? We need this table. And what other table do we need? We need to have the sales items table, right? Because it has the unit price and quantity so that we can calculate the sales or the revenue or from the swimsuits sale, right? So it seems that we have 2 tables, and the information we need is the unit price, the quantity, and also delivery date, right? Okay, so now I have a structure in my mind. So now it's time to write it out, right? So let's create a new query. And let me close other tables, save some space. So I will start, actually I can leave the select part open for now and work on it later because it's easier to work from the later parts, the from part, because we know that we have 2 tables here. So if you recall what we mentioned about joining the tables, right? So here, if I say, let's set the retailer sales items table as the left table, and maybe it's better to move the tables around. So I can close this. So let's say sales items table is the left table. The sale table is the right table, and if we want to generate the total revenue, what kind of join are you going to perform in this case? Okay, so let me do not, let's think about the join later. So let's use where, which is more intuitive, okay? So let's first use the simplest where. Okay, so earlier we said that we need information from the 2 tables, right? So let's just put the 2 tables side by side. Retailer sales items. So now this is something new here. Now we have the table names with spaces between the words. If that's the case, we have to enclose the table name within the square bracket. Okay. This is just like if we do not have the square bracket, the SQL will like have some error message. So we have to enclose the name within a square bracket if the name has spaces in between. And the second table is the retailer sales from these. And our condition is that So what's the attribute or foreign key that is linking the two tables? Retailer sales and sales item. Yeah, order number, right? So here the where will say the retailer sales items dot order number is the same as the retailer sales dot order number. And here I'm enclosing the order number within the square bracket because here it has a special character of the pound sign. So if that's the case, you also enclose the name within the square bracket. I'm going to work on this later. I'm just leaving it blank and later I'll come back. Okay, because from here I know the table information, I know how the tables are linked. So I'll work from where I know first, right? And we also want to make sure the delivery date is within May, right? So when you have multiple conditions like this, you simply just need to say and. You have two conditions. The first condition is that the two columns are the same. The second condition is that the delivery date is between May the 1st and May 31st. Now let's work on the select. So the question says, what is the total sales? So the final outcome that we'll get is just the number for total sales, right? So here from the sales items table, if we want to calculate sales, that's going to be the price by quantity, right? And we have to take a sum of all these relevant items that meet this criteria. So it's going to be sum of the wholesale price by quantity order. And we can give it a name, let's say May revenue. So we can execute. So we are going to get this 19,401 as the revenue made in May. So maybe I can save this this query as total revenue. Okay, total revenue. So because here we are just directly getting a final outcome of the revenue, right? We are directly calculating as taking the sum and then impose the conditions here. So now this is the intuitive approach, right? Let me show you this alternative approach. So if we look at the sales items table, right? If I ask you, okay, from this table, if you were to calculate the May's revenue, what information are you missing? Can you tell me if let's look at the sales items table and we want to generate May's revenue, what additional column or columns are we missing? Yeah, delivery date. We don't have delivery date, right? So then that is to say, if we want to calculate something from this table, we have to add the delivery date here. So one approach is that you can create two separate queries. The first query is that you are going to create a table that has order number, sales, unit price, and quantity and delivery date, right? That's a separate query. The second query is you are going to calculate the sum of the sales just for the delivery date within May, right? You can execute it separately. But we can also combine everything using a join statement. So here, let's create a new query and we can type it out and let's see how is it different from the one that we just did. So we're going to do select sum wholesale price. From, so here, a left join of retailer sales on and lastly where. We use the square brackets for the table name because the table name has spaces between different words. If that's the case, we have to use a square bracket. And the reason I put a square bracket around order number is that the pound sign is considered a special character in SQL. So we have to also use a square bracket here. So that's why if you have a chance to create these tables, avoid leaving spaces in your table names and avoid having these special characters in your column name. But in this case, we're directly using some table. So we have to put a square bracket. Then you do not have to use a square bracket. Yes. Right. So, okay. So here we're just saying, we are using the sales items table as our left table. So you can think of it as holding this as is, right? And then we are matching the information from the retailer sales to it using the order number as the foreign key, right? And the information we need from this other table is the delivery date. So you can think of it as joining the two separate queries, as I mentioned earlier. So in this case, you can also achieve the same outcome because if you run it, you'll get the same number here. So when you execute your queries, you can choose either approach, whatever makes more sense to you, right? I personally prefer using the left join because it tells me that, okay, first of all, I need the delivery date in this major table, right? And then I impose a condition, which is the delivery date. But you may find the other approach is more intuitive. So whatever you choose, because either way leads you to the same outcome, right? So I can save the second one as total rev alternative. Any questions here? Yeah, so in this case, you will find that if you hold all these constant, right, you keep your retailer sales items as your left table, and then you change the left to right or inner, you will have the same results. This is because I think I discussed this earlier. In this specific database, the order number from the two tables, they completely overlap. So in this case, it doesn't matter whether you use left or inner or right, but logically left makes the most sense because you're holding the left items table constant and add information to it. But it just happens that you will get the same result in this case. Okay, so I assume we're okay here. So let's take a look at the second practice. Okay, so now the second practice is what was the total shipping cost that BBB charged within May? Okay, so you have to think about where to get the shipping cost, right? And also you have to find the date information, right? And again, we are going to use the delivery date. So in this practice number 2, actually you do not need to join different tables. All the information can be found within one table. So this one should be fairly simple. And let me invite. All right, this is correct, right? So if you get to this 1,573, then that's correct. And let's first look at what table do we need, right? This is obviously this retailer sales. And we can get everything from this table itself because we have the shipping cost and we have the delivery date, right? So that is to say in the from statement, we only have one table and the condition is only the delivery date with between these two ends. And then total shipping cost, of course, we want to do a sum of the shipping cost. And that's it, right? So this one should be fairly simple. So first of all, how do we know we need to apply a sum? So this one, because if we want to get the total shipping cost, that is to say, like we have to add these numbers up, right? So like if I do it manually, I would filter this delivery date and retain these the ones with May numbers, right? I would do this, and then you can add all these shipping costs up. So that is to say you are performing a sum, and when we do a sum, it is applying that vertically to these variables. It is taking the sum like all of these entries here. So that is how we know that we have to use a sum. And in terms of which date we have to use, right? Earlier we said that the revenue is recognized when, revenue is recognized when the products are delivered, and also that's also the time when the shipping cost is generated, right? Because that's the time when you deliver. That's the process when the shipping is utilized to deliver the product, right? So here the delivery date is used. So yeah, I think just this is just a matter of practice. Once you practice more, you will get more familiar with how to use it. So don't worry about like now, because we are going to, this is why we are doing this exercise, right? We want to make sure everyone gets more practice and get familiar with this. So I'm going to save this as total shipping. Any questions here? Okay, so now let's look at the third one. The third one is a little bit challenging. The third practice, how much cash did BBB receive within May for the sales made during this period? So let me clarify. So in this question, I actually have two conditions. The first one is that the cash has to be in May, or cash has to be received in May. The second condition is that the cash is for orders delivered in May. Okay, so I actually mean the two things combined. Okay, so it has two conditions here. So this is the challenging part, and you need to think about how to execute this. So there are different ways to reach the same conclusion, and let's take a look at their approach. So it seems that they are using the cash receipts as, let's say, an anchor table or this major table to work on, right? And in order to look at if the cash received is for the order made in May, so they are bringing in the order information, especially the delivery date, from the retailer sales table, right? So that is to say, imagine while working on this table, what is missing is the delivery date, right? So that's what they did here. They do a left join, and they put the delivery date as one of the conditions in the where statement. And if you join the two tables here, the matching criteria. So here, it actually doesn't matter if you, because in this table, it's not a well-designed table. Okay, I just want to comment on that. It's not your fault or my fault. It's just like by design, this table is not well-designed. So in this case, you can either use a cash receipt number or this order number as your foreign key, because it just so happened that you have two columns. Like the cash receipt number is included in both cash receipt and retailer sales here, right? And the order number is included in both tables. So in this case, doesn't matter if you put cash receipt number or order number as your matching criteria. It will give you the same results. All right, so here either one is okay. And our first condition is that the receipt date is in May. And second condition is that delivery date is in May. So if you execute, you should get the same answer. So for example, I just want to illustrate if we change this to order number to get the same result. Yes, it's the same here. Now, let's say, can we do a different way, right? Because we say the left join. Okay. So now let me show you a different way, which is let's do the retailer sales as the left table. And we can directly switch this to cash receipts. And then if we execute, it's actually the same answer. This is because this table is not a very typical table that, like, in general we would work on. This is a very special case where we have complete overlap between the two tables in terms of these two columns. Okay, it's not always going to happen in real life, but it just so happens that in this case, they will give you the same answer. Now, you may ask me, okay, how do I know whether it's the right thing, right? So, like, I would just recommend, like, for example, in this case, either one makes sense logically. So I wouldn't really like mind how you get to that solution. I would just look at if the final outcome is the correct one. And if you really feel uncomfortable using joins, I realize that in most of our databases, especially when we have complete overlap of these columns, you will reach the same conclusion using where. So that is to say, you can revise this join using a where statement. So let me just copy paste this to another separate query. So here you can actually do from both of these tables. Where. So here, instead of having two conditions, we have three conditions, right? So if that's the case, you'll also get the same answer, right? So I would personally prefer using joins, right? But if you really feel uncomfortable, you can also use where. I just cannot promise that every time you use where, it will give you the right answer, because it just so happened that our data sets are very special, that these are interchangeably used, okay? But I think for the midterm exam, I think the database is still like this, so you can feel comfortable using where and join. Yes, yeah. So so for the joins, I mentioned something that is called anchor table, right? Let's just pull out the slides here. Okay, so the three types of joins, I think the most important is the left join, because once you understand the left join, the right join is just the reverse of it. So a left join is just saying that, suppose we have a left table, which is just a table on the left, or right table, you can define it in any way. And then you are holding one of the table constant or just as is. For example, if the customer table is our left table and we just want to add information to it, for example, here we're adding another column of amount. And in our earlier practices, you can think of we're adding this delivery date to the sales items table, right? So in that case, the sales items table is equivalent to our customer table here. So in this case, we're saying that we're performing a left join, which means we are adding information to our table to the left, or adding information to the left table. In contrast, a right join is saying that we're adding information to the right table. So in that case, the right table is held constant. But left and right, they are interchangeable, right? Because if you flip one, then you change how you say it. So the more important is just like, if you understand one, you understand the other. So the reason why in this case, we use a left join is that, imagine if we just look at this cash receipts table, and if we want to calculate the cash receipts for the orders in May, what's missing is just the delivery date from the sales order table, right? So that is to say we are holding this table constant and adding another extra column to it. And if we assume this is a left table, then we're performing a left join. So that's why in this version, so here, this is cash receipts. And the table to be joined is the retailer sales. Okay. So one thing that I can summarize for you is that in a join statement, so we have select. You can put anything after it, right? Depending on the requirement. From, so this is always going to be your left table. However you define your left table. And left join. And you are going to follow your right table, right? This is the syntax here. So your left table always go after the from, and the rest of the table is after the join. And so this database is special because we can also do it the other way around. So if we look at the retailer, if we look at, let me see, retailer sales table. So in this table, we can also calculate the cash for orders received, for orders made in May, because the only information that we are missing is just the cash amount in this case, if we hold the retailer sales constant, right? So that is why we can also flip this one and use retailer sales as our left table and cash receipts as the right table, and we get to the same conclusion. So this is very special, but either way works. Did that answer your question? It is difficult to give a definite answer as to should we use which. It just depends, because in some cases you have to like just use a left join, but in most of the database that we're using for this class, they happen to give the same results. It will give you the same result. So for example, if you use inner, it will be the same. Yeah. So I will stick to left because that makes the most sense to me. Okay, so let's save this query as let's say total cash. And you can save the other one, like whatever alternative you have, as total cash alternative if you want to review it. Okay. So are we fine so far? Is it so this part is a little bit challenging. So now let's look at the next practice. So the next practice should be more simpler. So now we have from our first practice, the total sales. The second one, we generated total shipping. So in this, if you read the case study, the BBB is going to charge for the shipping, and they are going to pay for the shipping company, like they are the intermediary between the customer and the shipping. So they collect the shipping cost. And then we generated the cash. So now the number 4 is to use all the 3 numbers that we generated earlier to calculate total accounts receivable. And here the accounts receivable is just the sum of the sales that we generated plus the total shipping. That's the total amount that BBB is to charge the customer. And if we minus the total cash that has been received, that net amount is the receivables, right? The amount to be received. So here, I can just give you this, we can go through this together. This one is simple, but there are some points that you need to know. So when we perform this calculation on just one number from a table, for example, if we want to add the total sales, which is from the total revenue table that was created, right? Want to add this number and the total shipping number. which is this one, and then minus the total cash. We just have to do very simply adding these up. So let's create a new query. So it's going to be just select. I believe we name Rev as our sales plus total shipping. The name is total shipping. Okay. Total shipping, and then minus cash, total cash. Okay, and we can rename this as, let's say, accounts receivable. And these numbers come from 3 tables respectively. Okay, so the first table is the total rep. Second one is the total shipping. Last one is total cash. So that's it. That's our accounts receivable. Okay. So in this case, we do not use a sum function because the sum function, as I mentioned earlier, it is applying the sum vertically to all these rows, right? But if we are just adding different numbers together, we do not need to apply the sum, right? Just directly write it out. So we can save this as total accounts receivable and write AR to represent accounts receivable. Okay, any questions for the previous one, previous practice? Okay, so if not, we still have 15 minutes. We can do the practice number 5. So practice number 5 is to find what is the best-selling product in the period covered by the data set. So here we do not limit ourselves to May. We look at the entire data set. So the final result, I want you to present 2 columns. The first column is the inventory's primary key, which is the catalog number. The second column is the total sales for each inventory. So here we have to use the group by function, right? While performing this calculation for each inventory. This is something that we did before, right? We are calculating the total sales amount for, in this case, for each inventory, but if you recall, we also did a practice for each order, so on and so forth, right? So here, we have to use a group by, because if we do it manually, we would use the sales items table, right? So for example, if I say, well, how can we calculate the total sale for, let's say, for this inventory, right? You would multiply these 2 and add up all these numbers. So here we have to use a sum. And let's say we rename it as sales and inventory. And from the sale items table and group by catalog ID, that's correct. So here we just calculated this like for each inventory, right? What if we want to sort? So if we do use order by and directly use the sales, this one, it will not run. It will give us an error message. So to address this, you can directly include the original form of this variable, which is sum of ones in parentheses. If you do this, and then use a descending, it will work. So in this way, you can rank your results in a descending way. But because like for this one, if this happens in an exam, right, don't have to do this sorting in your SQL queries. You can sort your results after you get table. For example, when you get here, you can also sort it from here, right? You can go from largest to smallest, smallest to largest. So, but if you want to sort within the SQL query, this is how to do it. You just include the original form before renaming it. So let's rename this as sales by inventory. And so if we do this, we know that so in this case, we can figure out this one is the best-selling inventory, right? This catalog ID BBB 684. So that helps you find that answer. So for the next class, I plan to go through the last question here and also do a review session, a very quick review, and I will go through the assignment to explain to you the last 3 questions where you had issues, right? So that's the plan for next time. And I'll see you on Wednesday.